The second part of this chapter 5 is proportions. And so today we're going to be, in this video, going to be talking about proportions, and by the end of the lesson, you should be able to determine if two ratios are or are not proportional. Now remember, I'm going to be highlighting stuff. That just is how I let you know what I'm talking about. You don't have to highlight everything that I highlight. Now, and the essential question is, which two methods may be utilized to determine if two ratios are proportional? So you're going to be learning about two methods that we can check to see if something is proportional, and so that's going to be the whole topic for this video. Now let's go ahead and start off with some vocabulary. A proportion, probably help to define proportion. A proportion is an equation stating that two ratios are equivalent, which means that they're equal to one another. Two quantities that form a proportion are called proportional, which seems very obvious. So if you hear me refer to some two quantities or two, let's say, ratios as being proportional, it means that they're equal to one another. And so in this example, 2/3 is 2:3 as 4:6, or 2/3 is equal to 4/6. That 4/6 can simplify down if we divide both sides of the fraction by 2, can simplify down to 2/3. And 2/3 is equal to 2/3, and so because even though the ratios are written differently, they still hold the same value. They still have the same simplest form, and therefore are proportional. There are two ratios that are equivalent. So let's do an example. And this stuff is really straightforward. I don't want you to overthink it. I know that some people have a tendency to see math and automatically think it's supposed to be hard. This is definitely not one of those sections. So in example 1, determine whether ratios form a proportion. Tell whether 6:4 and 8:12 form a proportion, or 6/4 and 8/12 form a proportion. You don't necessarily have to use that 6:4, 8:12 vocabulary, because you can recognize that these essentially form fractions. So 6/4, is that equal to 8/12? How do we check? Well, we can check by reducing the fractions to simplest form. So we're going to reduce the fractions to simplest form. I do want you to write this down. So if we're reducing the fractions to simplest form, let me go ahead and change the color of this one. Then 6/4 reduces to 3/2 if we divide both of those numbers by 2, or if we simplify both of these values by 2. And then 8/12, if we divide both of those values by 4, the greatest common factor, reduces to 2/3. And even though they have the same, so don't get tricked here, even though they have the same numbers, you can notice that we have 3:2 as 2:3, or 3/2, which is not equal to 2/3. So we would say that no, the ratios are not equivalent. So do the ratios form a proportion? If they're not equivalent or they're not equal, then they do not form a proportion. They don't reduce to the same simplest fraction. So we would say that they do not form a proportion. Now I got some heavy writing here for you, but I do have a second method for determining whether the values hold a proportion or not. So let's go ahead and write this down. A second method of checking for proportional relationships. So here is a second way that you can check. If the quotient of the ratio on one side of the proportion is equal to the quotient of the ratio on the other side, then you have a proportional relationship. Now, what I just said, I used the word quotient. What that means is the answer to a division problem. And we know now that fractions are essentially division problems. It's the top number divided by the bottom number. So what I stated just now is that if you can divide the fraction on the left side to equal the answer for dividing the fraction on the right side, then you have a proportional relationship because the fractions are equal to one another. So if the quotient of the ratio on one side of the proportion is equal to the quotient. I know this is going kind of slow, but I definitely want you to just be comprehending it as we go. So if the quotient of the ratio on one side of the proportion is equal to the quotient of the other ratio, then the ratios have a proportional relationship because they're equal to one another. So for example, going back to that example we just did in example 1, we were comparing the values 6 over 4, or 6 to 4. We were comparing that to 8 to 12. And if we take those values and we divide the numbers that are being presented, then we would get that 8 to 12 simplifies to 0.6 repeating, or divides into 0.6 repeating, while 6 over 4 divides into 1 and 5/10. And so you can see that they are different values, and because they're different values, because the quotients are different values, they are not equal. And so they are not proportional. So just a second method of doing it, and the reason I wanted to present this method is if you get a fraction that you cannot find the simplest form for, but you know how to divide the numbers, then you can at least check that way. If you get confused on the simplifying or reducing, then you can always divide the numbers and determine whether they're proportional in that method. So we've discussed two methods. Reducing the fraction to simplest form, that was our first method, and then our second method is dividing or determining the quotients of both of the ratios. In example 2, we are going to be determining whether two quantities are proportional. So here we have a ratio table, and we've got our x values and our y values, and we need to determine whether the x values are all proportional to the y values, which means that we're going to be doing multiple checks. So how are we going to determine whether they're proportional or not? Well, we just discussed that if they are proportional, that means that all of the values, all of the ratios are equal to one another. So we need to ask ourselves that question. That's the question that we're asking here. Are all values of ratios x over y or y over x, either one, equivalent? If so, then the values are proportional. So that means that we need, and we're going to label this as x1 and then y1. We're going to label this as x2, y2, x value number 3, y value number 3, x value number 4, and y value number 4. And so in order for this ratio table to have a proportional relationship amongst all of its x and y values, then we need x1 over y1 to equal x2 over y2 to equal x3 over y3 to also be equal to x4 over y4. They all have to be equal in order for the ratio table to have a proportional relationship. So in order for x and y to be proportional. So how are we going to check that out? We're going to compare them. We're going to set them equal to one another and then simplify them down and see if they really are all equal to one another. So for the first example, we can put x1 over y1. So x1 is equal to 1/2 over y1, which is 3. And is that equal to x2 over y2, or 1 over 6? Well, we have a complex fraction here. We have 1/2 over 3. So we're going to need to simplify that down. So we need to simplify this down in order to determine whether it is equal to 1/6. So let's go ahead and do that. So we're going to do 1/2 divided by 3, which is divided by 3 over 1. We're going to change flip this because we don't want to do 1 divided by 3. That's going to give us a decimal. So there's going to be 1/2 times 1 over 3, which is equal to 1 over 6. So if 1/2 over 3 simplifies down to 1 over 6, then that must mean that those two values do hold a proportional relationship, those first two. Because 1/6 is equal to 1/6, so that means that x1 over y1 to x2 over y2 is proportional. So now we just need to keep checking the other ones, x3 over y3 and then x4 over y4 to determine whether they are also proportional. And if they all are proportional,